Hello, it's Dr. Gibson. Welcome to this week's the Module 1 video, Statistical Foundations. By Statistical Foundations, what I mean is the foundations for the quantitative statistical tests that we will be learning how to use in this class. Here are the highlights of our video today. First, we're going to talk about levels of measurement, and then a little bit about the mean, standard deviation, and z-scores. Some about distributions in general and the normal distribution in specific. A little vocabulary with population versus sample. And then finally, a few little miscellaneous items right at the end. All right, so levels of measurement refers to different levels or maybe qualities of data that we get for use in our studies. So you'll see I've got three columns here. The first one is SPSS, and this is how SPSS will refer to these different levels of measurement. The middle one is how a traditional stats text would refer to them. And the last one is how a research text like Aaron would tend to refer to them. Some of the research texts kind of use their own terminology, but what Aaron's doing is pretty typical. So the first category, or the one that gives us, that is the least of the information, is nominal. The data file would just be, with this data, is just going to be words. So SPSS and the Aaron text both call it categorical. So in other words, there's a number of categories. Each one will have its own word. So you might have, a few, 2 or 3, up to 7, 8 categories. And then the data file would literally just be one of those, the title of one of those categories, right? So maybe up to 7 or 8 different words just repeated over and over again. Really, all we can do with that is count how many times each category appeared in the file. The next is ordinal. So this is a little bit better. There's a little bit more information. What's happening, it's usually numeric. There might be letters sometimes like A, B, C, D, but there's a ranking. Okay, doesn't tell us how close one is to the next, but it does put things in order. Likert scale data would be like this, like something that says, rate this from 1 to 7 or whatever. So a stats text is going to call this ordinal because that's really all that we've got. The only thing it's giving us is the information about the order. SPSS is going to call this scale, and then our Aaron text calls it numeric ranked. This data is useful for most of the tests. The statistical tests that we will do, the first category up here is only useful for the last test that we'll do towards the end of the course. The next category is interval. We're getting a little bit more useful here. This is a little bit unusual kind of data. Standard examples would be calendar dates or temperature data in either Celsius or Fahrenheit. You can do most of the things that you want to do, but division doesn't really work. I mean, you can divide the numbers, but it doesn't mean anything with this kind of data. All right. Our Aaron text is going to call this numeric equal interval, and SPSS again is going to call it scale. The final type of data is ratio. So there's no restrictions on this. You can do any kind of calculation you want to do. Again, the research text like Aaron is going to call this numeric equal interval, and SPSS will call it scale. Okay, so the reason I wanted to talk about this is to highlight the idea that there are different types of data and show how the 3 different rating systems really that we're going to kind of run into, how they relate to each other. All right, 2 key terms, the mean and the standard deviation. The mean is nothing more than the formal name for average, right? Add up all the numbers, divide by however many there are, that's an average, it's also the mean. Now, standard deviation, which is usually abbreviated SD, is the average distance from a data entry in a data set to the mean of the data set. So in other words, the standard deviation is a measure of a data set, same as the mean, right? You get the mean of a whole data set, standard deviation of a data set. And it's just what it says right there. It's the average distance from a data entry in the data set to the mean of the data set. Last little bit for this slide, z-scores. Here's the calculation for it in the numerator. So x stands for data value. A z-score is something that's calculated for an individual data value, right? So with x being the data value, the z-score is going to be data value minus the mean of that data set, and then the quantity divided by the standard deviation. What this calculation gives us is the number of standard deviations above or below the mean. All right, so we get a number, that's how many standard deviations you are away from the mean, and then if the number is negative, it's below, positive, it's above. This is used for a variety of things. All right, distributions and the normal distribution. So if you're in a statistics setting, when someone says or you read the word distribution, they mean a probability distribution. And a probability distribution is a pattern that data follows that has an element of randomness to it. So in other words, what the pattern is going to say is data values in this area give you a probability of data values in different areas, right? And so as the pattern changes, what's going to happen is different parts of the pattern are going to give you different probabilities for getting data values in that area. So it's a pattern of probabilities, which then that has an element of randomness to it. Now the normal distribution is the most common probability distribution. By far, that doesn't mean that most data is distributed normally, it's not, but normal is the most common. You will see that our errand text uses z-scores combined with a normal probability table, in other words, probabilities taken from a normal distribution, to find the likelihood of data being in a given range. It's doing this to give us a feel for what a probability distribution looks like and how it works. Last thought here is for some of the things that you'll be calculating this week, if you already know how to use a graphing calculator or Excel to do them, one of the built-in functions there, please feel free to do that. However, if you don't know how to use the technology, it's really not worth learning how to use it. We're only going to focus on these things in a way where you would calculate them individually just for this one unit. It's only going to be a few questions of each type. Our purpose is to help students get a good sense of what these, what's being measured, what these things are. All right. So if you can use the technology already, great. If not, don't worry about it. You're only going to have a few questions to figure out how to do. All right. 2 vocabulary words: population versus sample. So the population is all the data about whatever is being studied. Okay? Usually populations are very big. A sample then would be a sample taken from the bigger population. All right? Why would we make a point of population versus sample? Well, statistical tests like the tests we will use are most often used with sample data to infer or estimate characteristics of a larger population. In practice, data for an entire population is usually impossible, or at least too expensive to get. So we use samples, and thus we want to understand the difference between a sample and a population. It's possible to get population data in some situations. It's just quite unusual. A few miscellaneous items. So our textbook, the errand text, talks about a rectangular probability distribution. If you've had some statistics before, this is usually called a uniform distribution. What it means in a uniform or rectangular distribution, all data values and all ranges of data values that are of the same length have equal probability. All right. Another term that's used in the error text is haphazard sampling. This is usually called convenience sampling. So if you've seen convenience sampling in something else you've done, that's what Aaron means by haphazard. And my last little comment here in this section, in real life, data never exactly follows a particular distribution. I mean, I've never seen it where it exactly follows it. All right. Also, there are a large number of possible distributions. We are focusing on the most common distributions and the most common statistical tests. All right, now it's your turn. Time to go do your readings and the videos and the errand text, work through the homework. I'll see you here next week.